All right, I've got a weird one for you today. We're doing a deep dive on a cable.
Just a cable.
Yeah, specifically the NTI E-LLDC-100. It's 50 feet long. You lay it on the floor, and it costs $886.
It sounds ridiculous when you frame it like that. Almost $900 for a wire.
Right.
But that price tag is actually the most important clue. It tells you this is not some gadget you buy at a hardware store. This is serious infrastructure.
And that's really what we're trying to unpack here. Why a spool of wire costs as much as a decent laptop. I mean, usually cables are just clutter.
Mm-hmm.
But looking at the specs on this thing, it feels less like a cable and more like a building's nervous system.
That's exactly how you have to see it. If you're running, say, a huge data center, you aren't really worried about a full-on flood.
By then it's too late.
Way too late. You're worried about the small stuff. A single bead of condensation dripping from a pipe inside a server rack. That's the nightmare this thing is built to catch.
And the key is right in the name, isn't it? The location part. Liquid location detection.
Right. Most water sensors are just a binary alarm. They just scream water.
Yeah.
And then good luck finding it in a 10,000 square foot facility.
So you're just running around in a panic.
Exactly. This system is different. It measures resistance along its length. So it tells you, hey, there's a problem at exactly 42 feet.
Which is just wild when you see how little it needs to trigger. The spec sheet says a liquid depth of just 0.1 inches.
That's 2.5 millimeters.
And the puddle only has to be, what, 0.6 inches wide?
Think about that. That's not a puddle. That's a few heavy droplets. It's catching the problem before it's even a problem.
But here's the engineering part I found fascinating. You're building something to hunt for water, so it has to be super sensitive to conductivity.
Mm-hmm.
But it also has to sit in that water without, frying its own electronics.
That's the whole 100% waterproof electronics claim. It sounds obvious. Of course, a water sensor is waterproof, but it's actually really hard to do. You need sensors exposed to the elements, but the internal circuits have to be perfectly sealed.
And they have to survive in some pretty nasty places. The operating temperature is 32 up to 167 degrees Fahrenheit.
So it'll work in a freezing warehouse or a scorching utility closet packed with servers. And get this, the bend radius is under 0.4 of an inch.
Yeah, 0.375 inches.
Which means you can snake this thing through the tightest, ugliest parts of a building. It's designed to just sit there in the dark and wait.
Okay, we have to address the statistic that made me... I actually had to do the math twice on this. I was sure it was a typo in the data sheet.
I had a feeling you'd land on this one. The MTBF.
The meantime, between failures, it's not just a big number, it's absurd. 10,869,188 hours.
10 million hours, yeah.
I ran the calculation. That's over 1,200 years.
Staggering, isn't it?
You could have installed this cable during the height of the Byzantine Empire, and it might just be due for a replacement today. Why? Why on earth does it need to last that long?
Because where this cable lives, failure is not an option. It's not an inconvenience. It's a full-blown catastrophe.
Right.
If your phone charger breaks, you're annoyed. If this cable fails to detect a leak, a hospital's entire record system could go down. The cost of failure is infinitely higher than the $900 price.
So it's a completely different philosophy from consumer electronics.
Totally different. Your phone is built to be replaced in 3 years. This is built to outlast the building it's in. And remember, we're only looking at the 50-foot model.
Oh, right. It's scalable.
It scales up to 4,000 feet.
So you could effectively wire up almost a mile of this stuff.
You could turn the entire floor of a massive cloud computing facility into one giant continuous sensor. It's about vigilance at an immense scale.
It really does reframe that price tag. You're not paying for 50 feet of plastic and copper.
No.
You're paying for 10 million hours of certainty.
You're paying to sleep at night, knowing that if a pipe starts dripping at 3 a.m., an alarm will go off before a single server gets wet.
It does make you think, though. We have the technology right now to build a simple electronic sensor that can last for a millennium.
We absolutely can.
So why does my smart toaster die after 18 months?
That is a fantastic question for a very different kind of deep dive.
Something to chew on. All right, that's all for this look into the world of ridiculously reliable cables. Thanks for listening.